algebra 2, we're going to be working with a lot of exponents. Exponents in different situations. Alright? So we have to understand how we can work with them. So they said the question, how do you simplify algebraic expressions with exponents? So here's our objective today. So our objective is that we're going to evaluate expressions with exponents using our exponent properties. And we're going to use exponent properties to simplify algebraic expressions. Yeah. The first thing that we have to understand is a monomial. What is a monomial? A monomial is one term.
A variable, a number, or the product of a number and variable.
Right, so a monomial is a term. It's a variable, a number, or a product of a number and a
You got
variable.
right there?
Yeah. So what does that look like?
We taking notes on our paper this time?
Yes.
Why is so shot like that?
So what does that look like?
Wait a minute,
What does that say?
A monomial. It's M-O-N-O-M-I-A-L. Monomial.
If you ain't know.
All right. So
Yeah, I know it
We can't see how we learned it out.
so we're gonna do what? We're gonna listen.
Read it first, read it.
That's what I said. A monomial is one term. A variable, a number, or the product of a number and a variable. So here we go. This is the parts of a term. We just talked about it can be the product of a number and a variable. What do we call that number? We call that number a coefficient.
I know all that
What do we call it? So, and then we have the base. The base is what is the number or variable that has the exponent attached to it. So, when we talk about a term, we said that it's a monomial, so it can be 2x cubed plus 3x plus 2. Each one of these is a term. Right, Creation? Each one of these is called a term because it's a monomial, it can be a number, it can be a variable, it can be a variable, or it can be the product of a number and a variable. Alright, so we have our coefficient, our base, and our exponent. Alright? And of course we know whenever we're dealing with exponents, it means, the exponent means that we're multiplying our base by itself, the number of times that the exponent expresses. Everybody got that? Alright, let's move on. So here's some properties that we're going to consider. It says consider what happens when you multiply two powers that have the same base. So if we have the same base, what can we do with our exponents? Alright? And then it says consider what happens when you divide two powers that have the same
You
base.
got right on that?
No, I'm just saying it says consider. Alright? So consider. What do you think will happen if we have two powers, we're multiplying two powers that have the same base? What does it look like is happening there? We're looking at the same base. They have different powers, but what is happening with, consider what's happening with the power when we multiply the two powers. The two terms, same base, different exponents. What's happening? Yeah, it's multiplying by itself.
Yeah,
But what is happening to exponent? What do you think will happen with our exponent?
Number two, the
the exponent?
right? But what's happening with the exponent? Are we multiplying the exponents? Look at the exponent. What do we do with the
We
exponent?
added the same number.
We're adding the exponent. So whenever we have like bases, whenever the bases are the same, and we're multiplying, but they have different exponents, what we do is we add the exponents. So that's what it's saying. And then look at what's happening with our, when we're dividing.
So now, calculate
I'm listening.
Can I come up here this time and do my part?
Oh, yeah, sure.
You sure? Okay. I'll be back in like 10 minutes.
That's not lunchtime. All right, so when we have like bases and we're multiplying them, different exponents, we add the exponents. When we're dividing, what are we doing with our exponents? What do you think we're doing?
We multiply,
No, if we're dividing now,
divide, subtract.
we're subtracting. So when we're multiplying, we're adding. When we're dividing, we're subtracting. All right. So here's what we could look at.
So whenever the base is, hold on,
Right.
go back.
So when you have like bases,
Go back to the.
right? When you have like bases, different exponents. When you're multiplying two terms with a like base but different exponents, we add the exponents. When we're dividing
Wait a minute.
two terms with the same base, different exponents, we subtract the exponent. Yeah. So now, here we go. So we're going to highlight what we just talked about. And then we're going to take a look at all of these properties that
Do
are,
we have to write that down?
yeah.
But can you go back right quick?
That right there? Wait, all that?
Please, thank you. You just said don't write.
I just said no. Didn't I just say
I'm
no?
not writing the whole thing, I'm writing the bottom part.
Okay.
Thank you.
I'm gonna put that shit
Yeah.
on Twitter.
What's
and
wrong?
I'm gonna
All right. So, all right, moving right along. Here we go. So here's the first one. So what is it's called? Yeah, you go write it. So here it's called the product of powers. All right. So when we have two terms, same base, different exponents, we add the exponents. All right. Same as the quotient of powers. When you have two terms, same base, different exponent, we subtract the exponent.
Do your work.
All right. So everybody, so we understand those two. All right. So now let's look at what happens when we actually multiply power of a power. So when you have, like I said before, that's a term. So once you have the coefficient, the base, and the exponent together, that creates one term. And if we want to put that term to a different power, that's called the power of a power.
That enough word for like a dollar something.
Yes, that's what we get when we divide.
What's wrong? What's wrong?
Result when we divide. Quotient. So power of a power says that if we take our term, say we take 2x cubed, it's in parentheses, we know that this entire term is going to be moved to whatever exponent is right outside the parentheses. Let's say we say it's to the second power.
No, shut up.
get my glasses.
Just a regular.
I like my favorite.
I know you're not gonna this, but right there. It's easy for you to see. Alright?
Why she talking?
So, what it's saying here that we're taking this entire term and raising it to this power or to this exponent. So what you do now with this one is you multiply the exponents. So it's saying, it's like me saying 2x cubed times 2x cubed. So everything in there will be multiplied by itself. So you're gonna have so you're gonna end up with 4x to the 6. You multiply the exponents. So it's gonna be 2x or 4x to the 6 power. Got that? Product of a power, same thing. So you have the exponent, the coefficient, your variable, you multiply times the exponent. Everything in the parentheses will be multiplied times the exponent. So it's going to be a to the m, b to the m. No, and I'm going over these. As I go over these, you write it down. All right?
I asked that the first time.
You got it?
I asked that the first time.
You got it? Devin, you got it? All right? So what happens when we have a negative exponent? A negative exponent.
Mr. Law,
Yes,
do
ma'am.
we have to only write the grand?
No, we're going to do over all of them.
Write all of them?
You tell me alone, she distracted.
Okay, so if you have a negative exponent, what happens? It becomes positive once you, with the reciprocal. So if you have, like it has here, a to the negative m, it becomes, your exponent becomes positive in the reciprocal of that number. So if you put 1 over, it will be a to the m power. And of course, a cannot be equal to 0 because you cannot divide anything by 0. It will be undefined. And then we have our 0 exponent,
So,
which says that anything to the 0 power is equal to, this one you should know from 7th grade. Anything to the 0 power is equal to?
0.
No.
1.
1, that number. Anything to the 1, anything to the first power is equal to that number. Anything to the 0 power is equal to
So,
1.
say it one more time.
Any number or term to the 0 power is equal to 1.
Okay. Hold on, let me grab that.
And then, last but not least, we have power of a quotient, where we have a over n, where we have the a over the b to the m power, and we multiply everything to that exponent. So it's going to be a to the m over b to the m. You got that? Right, Kadesha? Yeah. So here's an example. So if we have negative 2, so we have like bases,
I'm trying, that sounds like daddy.
we have like bases, different exponents. We're multiplying it. What do? We have like bases, different exponents. We're doing a multiplication. What do we do with our exponents?
You multiply?
She said
We add them. So we're multiplying like bases, different exponent, so we multiply them. So what would we get over here?
2 negative 2 and 4.
You have to write that down.
2 to the base, 4 to exponent.
Negative 2 is the base,
2 to the base, and 4 is.
and 4 is the exponent, because negative 8 plus 4 will give us
Oh my God.
negative 4. So it's going to be negative 2
Yeah.
to the negative 4 power,
You know what?
12.
Oh, no, I'm not with no 12. I mean, but it's right
and then once we simplify it,
It's not.
Hold on. Once this is done. All right, ladies and gentlemen.
Watch our mouth.
Do we simplify further than that?
Then you simplify. So we simplified. Remember, once we have a negative exponent, it becomes positive if we create a reciprocal. So now we have 1 over negative 2 to the 4th power.
That's the final?
And once we evaluate that, it'll be 1 over 16. Because negative 2 multiplied by itself 4 times will give you positive 16. Because a negative times a negative will give you a positive.
Hey, that's the battle of
Where?
negative 8 and what's that with the 4 days?
Plus.
I went to Dr. Allo's. Get a little side
She's so
Shut up.
She made it sound like it's wrong.
Sound like a cat, man.
It do.
All right.
Sad cat.
Kadesha?
Miss Pearlie.
All right, so let's move on.
Hold on.
And I'll have you all do the next one. Do the next one for me.
We don't like that.
All right. Y'all gotta hustle. This is a hustle business. Come on.
That's a bad part. You got one too, Mom?
All right.
Wait.
We gotta do it for ourselves.
Yeah, so evaluate this one for me.
Mari. He's a Mari.
It's simple.
I'm gonna try.
What? You call him Mari. Mari, you call me Mari.
We said we gotta do it.
So what's happening with this one?
Oh my God, black sand underneath your feet.
That's three.
Yeah.
I want the last piece on the page.
No, because remember it's parentheses, so you're gonna, it's your actual. Right, so you're gonna divide it by, and then, yep. So that's 2 plus 2, but 2 times.
4 to no break.
I don't want to do 3.
So 5 minus 3
Right, so you got the first one, which is the 5 minus 3. And then you do, so you get to the second power. And then multiply, because they have the parentheses.
I'm
Okay, so, anybody, any volunteers? Any volunteers? What's our first step? What will be our first step? Amari.
Is it 81?
It is 81, yes, but how do you get to 81?
I did 5 minus 3.
Okay, so that's our first step, so we 5 minus 3,
Then I timed it
Right.
by 2.
and then you times it by 2. So it'll be 2 to
You shot 3
the 4th power,
and 81.
and then you get 81. There you go, very good. Kadesha, you got that? You sure? All right. Because you know, there's a lot of chatter over there.
You go ahead and change.
Boy, you not even writing up and down.
That's because I'm phoning a friend. I'm gonna get my notes on Deanna.
You need to be writing this down.
You will give me a picture that say don't scratch.
You said what?
Wrong.
Hey.
You said talk to you.
All right,
You should say roll up.
here's the last example that I'm going to give. All right, this is the last example, and then I'm going to give you independent work. So you have 2 to the 4th power to the 3rd power.
Evaluate.
to the fourth power to the third power.
So, do I multiply?
Yeah, what do you do?
You multiply 4 times 1 with the 3,
Yeah.
which is 12.
Right, so what's the
Marvin,
12 power?
you used only 5.
Do I do 12 times?
No, you go 2 to the 12 power, so you're multiplying 2 by itself 12 times.
After you do
And then, so this is for.
So we got to the 12th power. How do you do that on the calculator? Ladies and gentlemen, listen up. Kadeisha and folks,
He said, Jamal.
how you do it on the calculator? So you will put in 2, and then you will see, a little triangle hat over on the other side. See that little triangle hat? This little hat right here? This little triangle here. Alright? So you get 4,096. That's the answer, 4,096. One number, all the odd numbers.
Is that how you add July?
Here you go.
Add first.
Oh, here that is, bro.
Big bro. We just got an issue.
So we're working on the odd numbers.
You motherfucker.